everyone, welcome back to my YouTube channel. As you all guys know me, I'm Keerthana from Sri Venkateswara College of Engineering, Bengaluru. Currently, I'm studying in BE in Computer Science and Engineering from the Department of Basic Science. Today, I'll be discussing about the subject called Applied Physics for Computer Science and Engineering, particularly about the topic called Explain how to create animated characters using physics. Before going to our main topic, let us discuss about introduction. Physics-based animation is a powerful technique for creating realistic and dynamic animated characters. By leveraging the principles of physics, we can bring life to believability to our characters. In this presentation, we'll explore the process of creating animated characters using physics. Understanding physics. To create physics-based animations, it's crucial to have basic understanding of physics principles. Concepts like gravity, mass, friction, and collision are essential for creating realistic character movements. Familiarizing yourself with physics will help you to inform decisions during the animation process. Character design. When designing a character for physics-based animation, consider its physical attributes. Determine the character's mass, shape, and proportions to ensure accurate physics simulations. Designing characters with simple and well-defined shapes will make the physics calculations more manageable. Now let's move on to our next topic called rigging and articulation. Rigging is the process of creating a skeleton structure for your character that will be influenced by physics simulations. Ensure that your character is rigged appropriately, articulated to allow the realistic movements. Joint limits and constraints can be applied to restrict movements and maintain physical appearance. Now our next topic is physics simulation software. Utilize physics simulation software like Unreal Engine or Blender to create physics-based animations. These software tools provide built-in physics engines that accurately simulate real-world physics. Familiarize yourself with the physics simulation settings and parameters specific to your chosen software. Now let us move on to our next topic called physics constraints. Physics constraints are essential for creating stable and controlled character movements. Use constraints like hinges, springs, and joints to define the relationships between different parts of the character's body. Experiment with different constraint settings to achieve the desired animation effects. This is the pictorial representation of physics constraints. Applying forces and motion. Apply forces and motion to our character to create realistic and dynamic animations. Simulate external forces like gravity, wind, or collisions to influence the character's movements. Experiment with force strengths and directions to achieve the desired animation results. These are some types of force. Our next topic is collision detection and response. Implement collision detection and response to make characters interact with their environment. Use physics collides to detect collisions with their other objects in the scene. Define appropriate collision responses such as bouncing, sliding, or braking to enhance the realism of your animations. Balancing realism and artistic freedom. While physics-based animation aims for realism, artistic freedom is equally important. Adjust physics parameters to achieve the desired artistic effect, even if it deviates from strict physical accuracy. Finding the right balance between realism and artistic expression will give your characters a unique and engaging appeal. Now let's move on to our next topic called iterative process. Creating physics-based character animations is an iterative process. Continuously test and refine your animations to achieve the desired results. Iterative on physics parameters, rigging, and character design until you achieve the perfect balance of realism and artistic vision. Our next topic is combining keyframing and physics. Combine traditional keyframing techniques with physics-based animation for greater control and creativity. Use keyframes to define important character poses and moments, and let physics simulations handle in-between motions. This hybrid approach allows for precise control while still leveraging the benefits of physics-based animation. Considerations and performance. Physics simulations can be computationally expensive and impact performance. Optimize your animations by adjusting physics parameters and simplifying geometries when necessary. Balance the level of detail and accuracy with the performance requirements of your project. Advanced techniques. Explore advanced techniques like inverse kinematics and procedural animation to enhance your physics-based characters. Inverse kinematics for more natural limb movements and precise control over character interactions. Procedural animation techniques like muscle simulations can add additional levels of realism to your characters. Now let's study about case studies. Study existing physics-based character animations to gain inspiration and insights. Analyze how other animations have leveraged physics to create compelling characters. Learn from their techniques and adapt them to suit your own artistic vision. Troubleshooting. When encountering issues with their physics-based animations, start by checking the physics simulation settings. Verify that your character's rig and constraints are properly configured. If problems persist, consult online forums, documentation, or seek advice from experienced animators. Now let's move on to our last part of our topic called best practices. Document your workflow, settings, and techniques for future reference. Maintain a clean and organized scene hierarchy to improve efficiency during the animation process. Share your knowledge and experiences with the animation community to foster collaboration and innovation. Now let me discuss about conclusion. Physics-based animation offers existing possibilities for creating realistic and dynamic characters. Understanding physics principles, rigging, simulation software, and constraints is crucial. With practice, experimentation, and a balance between realism and artistic expression, you can bring your characters to life using physics. Thank you for watching my video. If you like my video, please do like, share, and subscribe.